I'll start by introducing Bruce. Bruce Hamilton is the president of GBMP, a Boston-based nonprofit founded in 1994 that provides Lean and Six Sigma assistance to manufacturing, healthcare, and service organizations. Prior to joining GBMP, Bruce spent 30 years in manufacturing, leading his factory to a Shingo Prize award in 1990, lean manufacturing terminology there. From 1996 to 1998, his factory was also a project site for the Toyota Production Systems Support Center, or TSSC. We had the pleasure of working with Bruce and GBMP this past spring and summer. They provided the content and the training for a cohort of 10 folks from the food and beverage sector and teaching them about lean tools and procedures for them to implement at their facilities across New England. The project was funded by an EPA Region 1 Pollution Prevention Healthy Communities grant and really helped draw together this intersection between lean manufacturing and pollution prevention, and specifically TUR projects, which each of the facilities focused on. We're putting together case studies based on that work right now, and we'll have that out for folks on our website by the end of December. So look forward to seeing that. And with that, we'll turn it over to Bruce.
Well, good morning, everyone. I'm happy to be with you today. I should just add that I spent 30 years in manufacturing before getting into consulting, and 16 of those was in production. And all 16 of those also were involved with continuous improvement. That's what I called it. It was kind of pre-lean, going back into 1985. The term lean didn't get into the vernacular until about 1990 or thereabouts. I like the term continuous improvement because it focuses on the process rather than something that sounds like a destination, which it never is actually. And also during that time, in manufacturing, the issue of managing your waste streams is a daily event, always issues, because in order to make products, there are all manner of chemicals and fluids. And so I've had more than a few personal experiences. My wife was a welder, had a reaction to chromium. So I have, personal experience with, the effects of toxic chemicals in manufacturing and the importance of controlling them. But lean manufacturing, interestingly, never really talked about that, certainly not in the early days. When we talked about, we were mainly focused on, as I say, things that get in the way of the work. And perhaps we turned a blind eye too much to how much, the use of toxic substances got in the way of the work. So it wasn't necessarily, in the founding days, wasn't as much of a topic as it should have been. The world has changed a lot since the 1960s, when a lot of this idea became available to all of us. The father of TPS, now known as lean, Taiichi Ohno, talked about waste. Okay, and his wastes were very specific, and didn't really talk about the importance of waste streams as I'm going to describe them today. And as I said, it's probably the nature of the era that we lived in, an area back in the 60s when the environment seemed infinite and these things were not so much of an issue. And I believe if Taiichi Ohno were writing his book today, things would have been very different. But in the preface to his book, I'm not going to read this quote, but you get the point. He was looking at this timeline and trying to reduce the amount in that timeline, because his discovery was that there's a whole lot happening in our work day, which is not actually work. Doesn't matter what that work is. Clearly, this was focused in the beginning on auto manufacturing, but pretty quickly we discovered that, yeah, those things that get in the way of work can exist just as well in healthcare or in administrative work. Those problems on that level are pretty much the same. As different as the venues can be, Persons come to work intending to get work done, but things happen and they just get in the way of the work. So lean was a term to say, let's take some of that excess, that fat, out of the process. And so we can shorten that time frame by getting rid of things that get in the way of the work. It was quite specific about what he referred to them as non-value adding. What that meant was the customer doesn't want to pay for it. It's non-value adding. We want to provide value to the customer, and the customer, as a customer, I was a customer as well as a supplier. I didn't always know about the wastes that were occurring at my suppliers' sites, but I was paying for them. And if I knew about them, of course, I wouldn't want to pay for them. And so we focused a lot on a particular set of wastes, and I'll cover them a little bit here as a starting point, because this is where, Mr. Ono began. These wastes on the left-hand side, the Japanese word muda has kind of come into the English language, and I'm not a big fan of, using Japanese words. Some of them really don't translate well into English, but it's fine just to say 7 wastes. And the interesting thing about these wastes is they all have a basis in industrial engineering. Every one of these wastes, you can ask the question, why not half? Why not have as much storage? Why not have as much transport? In my own business, it was pretty illuminating to start looking at what we thought was work and discover that a product maybe the size of my fist could travel 2 miles just inside my plant, bouncing around back and forth. We were transporting it, moving it around, and clearly if the customer knew about that, they wouldn't want to pay for it. And that increased the elapsed time. It just seemed to take forever to make a product. And when you looked at the actual work content that went into a product, it looked like maybe it could be made in 10 minutes. But when a customer asked us to deliver a product, we'd say you can have that in 14 weeks. So where did all that time go? And as a new person in manufacturing, this was kind of my discovery. You see here this comment from Mr. Ono was that 98% of the elapsed time to provide a product or service is non-value added. It's not even stuff the customer wants. And yet it's part of our day. We don't think about it. We just kind of turn a blind eye to it. We go on, we say, that's just the way things are. We store a lot of things. We move a lot of things. Overproduction was a normal part of my work. I didn't think of it as a problem. I thought of it as a countermeasure, that if we only built more, we wouldn't run out. And that was really an erroneous idea, because we were always building something, but not necessarily the right thing. And of course, that took up more space and we had to transport it. It included all of the other waste. When we produced more than was needed or produced it before it was needed, we had to find a place to put it. So all of these other wastes, like defects, occurred. And if you produced extra, you'd probably produce extra defects as well. Without getting into all of these 7 wastes in detail, they were present in every job. And we noticed them on the factory floor. And it was pretty astounding to notice what the impact was. And I'll focus on overproduction a little bit more in a minute, because when you overproduce, you produce more of every waste. And notice that there's no mention here of environmental waste, the waste streams, toxic use. But of course, if you produce extra of anything and you're using toxic chemicals, you're probably going to be having more of a waste stream there as well. So this was kind of something that happened inadvertently in our original thinking about lean, didn't come up a lot. So these were things that impacted the customer. You'd say the customer really doesn't want to pay for any of these things. Motion feels like work. It feels like work. If you're, you're hunting for a spanner to set up a machine, and you may be breaking a sweat, it may feel like work, but in fact, in this definition, that would be motion. You'd just be moving around and with no particular purpose. And the reason was that the spanner wasn't in the right place and you had to go look for it. It's amazing to me that even today, I'll maybe ask a question like, how much of your time do you spend each day maybe searching for things, information, people, machines? And people say, oh, maybe, an hour a day. And, that's a lot of time. Wouldn't we love to have that time back? And that's not moving the process forward, but it's also pretty frustrating when we can't get our work done. So these things were all there, and we were just assuming they were part of the job. Over on the right-hand side are two other types of waste that, we hear less about, but they had to do with more of the human condition. More meant, and this was very common in my business, perhaps in yours as well. There were times of the week or day when there was nothing to do. And then there were other times when it was extremely busy. And we struggled with that. We'd marshal people over to work on a product, at the end of the day, because it really had to go out, or maybe it's the end of the month or the end of the quarter. And then there would be this period of without work again. It was almost self-inflicted. The way we ran our business caused this kind of feast or famine type of flow. And you either had to schedule all kinds of extra resources for the max, or you rushed, or you put people into a process that maybe were not as well trained as possible as they should be. All of these things were bad, and they caused this other 7 waste. So more was a big problem. Same thing with Mori. Mori is a term for strain. You might think of it as ergonomics. It's the person who's pushing the cart with the broken wheel. It's the type of thing that makes a job hard and frustrating. And these things occur, and so they're bad for the person. They're bad for morale. They're bad for our health, and they also will create all of those 7 wastes. And there's also this thing which we refer to as mental Mori. Like, I'm given 2 instructions here. One of them, this is the guide for the setup, and this is the guide, the drawing for the part, and they don't agree. They can't both be right. How am I supposed to make a decision? All of these things were things that Mr. Ono referred to as wastes, okay? And together they represented a huge, it's hard to believe that 98% of that elapsed time would be non-value added until you get into this process. And I'm going to guess that many of you have already been into this process and you've discovered it. 98% almost seems low sometimes to me.
And Bruce, that's a great segue. We actually want to take a pause here and run a poll to see how familiar folks are with lean manufacturing and some of the terminology that's going to come up. So here, Pam's
Let's
running.
do that. Great.
Okay.
Thank you.
Great. We've got almost everybody participated. Go ahead and wrap it up, and I will share the results.
So it's interesting. I'm watching the poll populate, and it's maybe about what I expected. We're all kind of impacted by it in one way or another, but about 2/3 have some exposure, and a few who are involved. So that's great. Good. Okay. So I hope maybe after today, more of you be involved. I see 22% are involved in the lean program. And, in fact, you may be involved and not even realize it, because what I'm going to be talking about is basically problem solving. If you're dealing with problems, you're involved with lean. We're trying to eliminate those kinds of problems. So terrific. Is there something I need to do to share these results? Was that what I should do?
No, I already took it down. I think we just wanted to kind of share that, and you can move on.
Okay. All right. So I just have to remove it from my screen because it's blocking my presentation. It's on top of my desktop. Let's see what we can do about that. Well, let's see if I move on, if it disappears.
Yeah, I stopped sharing. Let me see if I can.
And it doesn't actually. So that's okay. I'll just pretend that I don't see it. It's okay. It'll be a constant reminder of the poll for me during the presentation. So I want to talk about, conceptual issues that I think are really important. And this is important from a standpoint of, toxic use as well as other ways, because I want to talk about toxic use reduction in just a moment, but in context of the waste I talked about. There's an important concept. The idea that Mr. Ono was trying to sell was things should flow. Things should not, and here's an odd term that is used often, they should not stagnate. So stagnate in an environmental sense has kind of that connotation of something that smells, it's bad. But the same word was used to talk about how material would not flow, how production would not flow, work would not flow, it would stagnate. It was a bad thing. So, the idea was that there were two flows, and this is important in terms of where we look for improvement. The first flow had to do with the flow of the product. If you were in healthcare, the flow of the product, it would be patients. But you notice in this drawing, which actually comes from one of the very first books on the Toyota production system, it's a shop which is making a couple of products, a shaft and a bushing are being made, so the flow of those parts is a separate thing, and they move from operation to operation. They're transported, we work on them, they're inspected, and they're stored. And those are the kind of things that happen with the material. So that's one flow, and all manner of things can happen in that stream. And this, in fact, is likely where all of our waste streams would occur as well. And then there's the work of the people. We call, the objects are the parts, and the subjects are the people and the machines that are actually working on this. And they're working on one thing and then working on another and working on another. And that's a whole separate stream. There's different things that we're looking at. We're saying there's a process flow, and then there's the operation flow. I have a particular job that I do. Maybe I'm an assembler, maybe I'm a welder, and maybe I'm moving the parts, but I have those jobs, and I'm moving this part, and then that part, and then that part, and they're all happening in sequence. And we hope it's in a sequence that the customer needs, but usually, my experience, it didn't always work out that way. So in that concept, then, we want to take a look at both of the streams separately. And Mr. Shingo, who is the creator of his name is on the Shingo Prize. It's a prize about excellence in manufacturing. He made a kind of an obvious statement, although today it's kind of funny because in this day of robotics, companies invest a lot to move material, when in fact Shingo made the point that if you would like to reduce the waste of transport, you basically need to change your layout. You can certainly move material, that I alluded to, having this to move material for miles in my plant. I could have a robot do that, but the transport would still be there. The time would be there. We could replace the person with a machine, but he referred to that as superficial improvement. That, in fact, is something that a lot of organizations continue to do, thinking they're making an improvement because they're taking human labor out of it, but they're replacing it with a machine. So we've got to be careful about that. And that's focused on the flow of material. And then there's the flow of the operations. I do this job, then I do that job. And, Mr. Shingo's discovery of that came through the Cheaper by the Dozen folks, Frank and Lillian Gilbreth, from the turn of the century. They clearly had an impact on lean today. They were, they said people should have a motion mind. We should realize that so much of the motion that people are engaged in do nothing to advance the product. And we need to reduce that motion, because whenever we're doing that, we're not actually working. We're not producing anything. We may be getting tired. I worked with a hospital in Boston a little while back, and the chief of oncology agreed to wear a pedometer for a week just because she was concerned how much she was walking between her work. At the end of the week, she reported that 40% of her week was spent just getting to where she was working. And her countermeasure, same as you would see in a factory, was she just moved faster. This woman walked so fast that I had to jog to keep up with her. She ran up staircases because the elevators were in the wrong place. So layout was important to her as well. Transport and motion, they both require that we look at these wastes, and we have specific countermeasures. And a lot of the lean that we described today has tools that we use to help reduce those wastes. So good, that's the waste that Daiichi Ono and Shigeo Shingo and some of these other dudes from the Japanese automotive industry were talking about. But what about this waste that maybe they were not thinking about so much? So 2006, the gentleman by Mitch Kidwell wrote an article in the AMA Target magazine. He was talking about a study that was done that acknowledged something that actually was becoming very clear to those of us who were implementing lean, that our waste streams were being reduced as we became more lean. As we stopped producing things that weren't needed, so did our energy costs go down. So did our use of water. So did our use of chemicals. The waste streams were reduced. We didn't even intend that our energy costs went down. That in fact, in my business, we went from 3 buildings to 2 buildings to 1 floor of 1 building. And we were producing more, and it had nothing to do with, anything other than, these steps that we took to reduce those wastes that Mr. Ono talked about. But at the same time, down went our air conditioning bill, down went our lighting bill, all of those things that were impacting the environment. Those were these benefits that we saw. And we sort of took them like, oh, this is a nice bonus. But in fact, in some cases, this bonus is the most critical benefit. So the point of this article was that we shouldn't just take these as inadvertent gains, but we should make this part of our continuous improvement. It should be part of everybody's thinking. And in our planning, we should be planning, as we're looking at those current conditions and target conditions, to be including this, what Mr. Mitchell referred to as the 8th waste, this environmental waste. So I have a short video here, and this is a video I made over 20 years ago. It's about a current condition and a target condition. So there's process waste in it, there's operational waste in it, and let's add in this environmental waste. And I'm going to ask you to take a quick look at it with me. And then if you want to comment, you can turn your mics on if you like, and just let me know what you see in this condition that you would improve. And any of these wastes of motion, walking, searching, waste of storage, producing too much, all of these things. And then we'll look at a target condition and see if any of that is improved. So here we go. I'm making some toast for my wife.
Perhaps move the toaster near the fridge, and in your slack time, clean the dishes in the sink.
Certainly could do that. Absolutely. There you go.
Also, take out all the things you need to make toast. It's more than just putting it in the toaster.
Could
And have all
certainly
that
prepare in
staged.
advance. Yes. Excellent.
All right.
Thank you for sharing.
You're welcome.
Organize your refrigerator.
Yes, you notice I didn't even look in the butter tray for the butter. I knew it wasn't there.
Put the toaster in the corner where the other corner.
Yeah, change the layout. You know, as Mr. Shingo said, if I want to reduce transport, I should change the layout. So yes, move the toaster.
Invest in a butter dish so the butter's where the butter belongs.
Yeah, there you go. The butter dish isn't even the right shape. I'm wasting space.
You could make your wife some tea while you wait for the toast to toast.
Thank you. There are other things that I could do. And the key point here is that my time is not the same as the machine's time. And until you actually go and watch somebody make toast, you don't think about that too much, but it's kind of excruciating just watching me stand there. There's many other things a person can do if a machine is doing work.
By the way, take the butter out first so that it warms up so it's easier to cut.
Yeah,
Right.
exactly. This would be that Japanese word mori. This is stress. Look at I'm an uneven.
How about a bigger plate?
Bigger
Yeah.
plate, yeah. There are an awful lot of opportunities here when you're observing a small process. Honey, I made you some toast.
Raisin toast?
You could
Nice.
have done the dishes.
Could have done the dishes. So you might have missed that last comment. My wife asked me if it was raisin toast, and it wasn't. Okay. So, and of course, this from my years of manufacturing and my frustration that we were working very hard on something, turned out it wasn't what was needed. Like information is really important. Okay, so here's a process, and it's got lots of those wastes in it. And you mentioned them. There's walking back and forth. We could reduce that walking. We could, organize the refrigerator. I'll talk about workplace organization in a moment. It's a simple concept on the one hand, but on the other hand, it's so hard to do because people like me leave our refrigerators that way. I'm that person who leaves a tool in the last place he used it, and then I can't find it again. So all of those, so part of this has to do with technical solutions, and part of it has to do with, let's say this adaptive kind of condition where we have to learn to do something new. It's about people. Okay, so lots of opportunity. Any other comments before we look at the target conditions? You have some very good comments. Thank you.
Well, I would recommend looking at a short order cook and seeing what he does with his slack time. There's none.
Jesus.
So you want to outsource?
Yeah, well, I'm
In
just
my
saying.
business, I'm trying not to do that. I'd like to keep manufacturing here in Massachusetts. But there's all manner of solutions. Let me ask you this. Is there anything here from the standpoint, any environmental waste that you see? This is a harder one.
You could get a more efficient toaster, I guess. That seemed to have taken a really long time. So I don't know if there was extra energy that was used there. And I don't know, did you want toast? Because you have two there yourself, and I'm not sure if you really wanted toast or
So
you just made four.
You raise a very good point. Why did I make 4 slices?
Go ahead, Randy. Did you have a comment? No. One of the thoughts I had was that because the butter was not softened, you had to use more than you needed.
Yes, I did. And that would be there's an excess right there.
Plus, we had the fridge open for a while.
Fridge was open while I was searching. A use of energy. Yeah, you have to, if you're looking for those things, you see them. And I was saying to Joy yesterday that I've actually played this video. It's been played thousands of times, not just me. It's kind of out there. But depending upon the audience that looks at it, you get a very different take. So if it's played in a healthcare environment, there's a lot of discussion about cleanliness. And if it's played in if machinists are looking at it, one of them will say, well, the shape of the butter dish is wrong. And someone of you noticed the dishes in the sink, and of course, and we'll look at that in the target condition. And but the target condition is really your next current condition. If this is continuous improvement, once we make an improvement, and I'm going to show an improvement. And it has, I think, all of the changes that you suggested, maybe, and some more. Like you've noticed that the toaster took a long time, but did you notice how long I waited before I even started the toaster? 1 minute. It would have been nice if you have something that's clearly a long process and perhaps a better toaster. That would be an operational improvement. But perhaps this is just how much time it takes to toast. You know, there is, if the toaster is adding value, we could look at a faster way of toasting, but the current state of technology here is that, you know, toasters have a way of drying out the bread in such a way that you get that golden brown look, and that's what it is. But that doesn't mean that we couldn't investigate that as well. So there's 100 ways, different directions you can look at this. And all of them have to do with providing more value to the customer and in a shorter time in this case, okay? So it's taken us 4 minutes and 12 seconds. Let's take a look at what I'm now calling the target condition. And this is, you know, the word I'll use is Kaizen. It's continuous improvement. We're solving problems. We're looking at the current condition, and our observation, this is science, is telling us that we think there would be a better way. So I've got a better way here. My wife and I sat down and we talked about this, and here is our target. But think of it only as your next current condition and see what other wastes you can find, including environmental wastes. What type of toast would you like?
Wheat.
Okay. How many slices?
Just one, please.
Very good. You see, I'm already a happier person. I'm whistling a song. I've got using my time differently. I'm not just standing there. People hate waiting. But do you see conditions that maybe you would improve?
Yeah, I wouldn't let the dishes stack up in the sink like that.
Exactly. Like that's waste of storage. Like, why should we move the dishes twice? Isn't that what the dishwasher's for? In this case,
you could have taken the butter out of the refrigerator now.
And in fact, the butter is out. Thank you. It's the butter sitting out there and is now softened, so that I will not be using excess.
One thing that I always worry about is having a toaster underneath the cabinets. I worry about the potential effect of the heat on the cabinet.
Yes, indeed. Yes, indeed. And so this is why when we make a change, we have to exercise it and look very carefully. In fact, it's worse. It's sitting underneath those paper towels. That's probably not a good condition at all.
The ergonomics of filling the dishwasher weren't great. If you were doing that a lot during the day, you might want to change that.
Ergonomics, absolutely. Bending, stretching, reaching, all of those things, opportunities for improvement. And I'm nervously watching those paper towels.
Not letting stuff pile up in the sink to begin with would eliminate the ergonomic problem too. You're doing
That's
it one
true.
at a time.
If we did it a little bit at a time rather than all at
All
once.
set.
Thanks,
Use a reusable rag to clean things.
Reusable rags, yes. So there's an environmental waste, and thank you for that. Using a lot of paper towels there needlessly. You know, I actually had the vice president of HR for, I'll just say, a major window company in the Midwest send me an objection telling me that I was promoting bad hygiene because I'd touched the toast after wiping the sink. And I thanked her. I said, you know, yes, exactly. This isn't something I'd thought about. There's a lot going on, and your perspective, you know, your expertise gives you an opportunity to make improvements, and they're not all about time. So things are safety you've talked about, there's ergonomics, the use of excess materials, yes. How about the fact that I only had one slice of toast in the toaster? Would that ever happen in manufacturing, where we would run a machine with only a quarter of the load?
No.
Not too much, no, because we'd say, well, that's not efficient. It's a huge waste of energy. Okay, and that's why I made first time through, I didn't know what the customer wanted, but I knew that the machine had 4 slices, so I made 4. And certainly I could say, I could show you the calculations that showed you that that's more efficient, but of course, if the customer doesn't want it, that's not really efficient. Might be scrap. So all of those things are part of our observations and our opportunities for improvement. So I must tell you, when I showed this once before to a group of environmentalists, they had a lot to say about the dishwasher. And this is not an expertise of mine, but they felt that there would be more effective use of water if I learned how to wash dishes by hand. Is that true?
No, I've heard that it's more efficient to use your dishwasher.
Yeah, so it was. It's not a field of expertise for me, but I think a dishwasher is they're designed to use a minimal amount of water. They use quite a bit of energy, to be sure, to heat that water. So, but that's another issue as to how much energy is used for the dishwasher. Maybe we would look at which dishes were used, and there's all these different observations that can be made when you look at a process. And originally, when this video was made, it was made to show the importance of direct observation. You have to go and watch, because otherwise you just don't know what's happening. And the other was that a whole lot of things happen in the process which can make an improvement. In this case, the elapsed time dropped almost in half, but at the same time, the job was easier, it was better. We did what the customer wanted. And why shouldn't we add in, thoughts about waste streams as well, about toxic use. So there's that opportunity.
There's
So
lots
thank you
of
for-
great comments in the chat as well, Bruce. Lots of ideas about things that could be done, so we can look at that later.
Yeah,
But great
I'm
job,
sorry
everyone.
that if I start to look at the chat, I probably would lose my
No,
train of thought.
No, and
But,
I won't summarize them all, but I really do like, lots of good thinking and so for example, Walter points out that in that first scenario, you could really look at the toast as the chemical or the product, and the waste really is leading to, chemical waste. We looked at upstream, we have comments about looking upstream. There's a lot about trade-offs there. And as Daryl points out, there's really no easy answers. So you're right, having to really pay attention to what's happening and look at all the factors is super helpful.
and the comment about trade-offs is very insightful too. That is a fact of life, that we're talking about these wastes, but you're often faced with a trade-off. If you have less of one waste, you can have more of another. And now you have to make a decision, which depends upon the circumstances. As a planner, you make the best decision, the least worst decision sometimes for the conditions that you have. The ideal doesn't change. I'd like to have 0 wastes, and I'd like to have including 0 environmental wastes. But the practical matter is that what's the target? What's the best we can do now? So I wanted to talk now a little bit about the countermeasures that Lean uses and relate them, if I can, to your work in toxic use reduction planning. This is a busy slide, and this is a slide which comes from the Toyota Production System Support Center, the division of Toyota. It's a bunch of very smart and experienced people, a lot smarter than me, who have said, yeah, there's a technical part to this, and it's based upon reducing those wastes. So this is a technical science. It's over here on the right, and I don't have time in today's session to go through it, but I will go through pieces of it. The technical part says that you first of all have to have stability in your system. It's there at the base. And then you have to have some clear instruction, we're going to call that standardized work. You need to, the term that they'll use is levelized, or is a funky a Japanese word there says heijunka, which says, like, could we just have more level work? Could we at least try to level out the workload? Because if we don't, it becomes very hard for people and machines to complete the task. And then there are two pillars, one of which has to do with, let's say, flow of material one by one in the quantity that the customer wants it. And the other that has to do with solving problems one by one. Let's not let problems fester. When they occur, let's have means to solve them on the spot if we can, or as quickly as we can, so that they don't grow, or so that they don't persist, so that the problem that we encountered at 8 a.m. doesn't recur at 9 a.m. and then at 10 a.m. We need to fix those things. And the goal being, we want to provide to our customers the highest quality with the lowest cost and the shortest lead time. That's our goal. But in order for that to happen, and this is something that's often been missing over the years with implementations of Lean, is you got to create the right environment. For example, a lot of companies will say, we have a quality system, but maybe we don't have a quality culture. What I mean by that is, yeah, we may have all the tools to fix problems, but maybe I'm afraid to report that problem because I'm afraid for my job. I'm afraid that I might become the problem. So I keep it to myself. So creating that favorable environment is really important. And this, I'm sure, has applicability to toxic use reduction as well. We need to have persons who are raising a hand. In the Lean world, we say, make problems ugly. Don't sweep them under the rug. Raise your hand, let us know, and then we're going to fix that problem. And that also is part of it. That part of that favorable environment is when we have that problem, say, thank you for fixing that, for reporting that problem. Let's work on it together. Let's fix it. Because we want to motivate people to be surfacing problems. And in the kind of a traditional sense in manufacturing, and I grew up in traditional manufacturing, we just did a good day's work in spite of all the things that went wrong. We were long suffering. We just dealt with problems. We didn't maybe have workarounds, but there was no idea that we're all going to be an army of problem solvers. We were there with our eyes and hands, and that was it. And certainly for management, it means showing that strong commitment. The same would be true of toxic use reduction, that we need to be serious about this. It can't be something that, yeah, I know we got this regulation, we have to follow this route. No, it's not that. That it's very important. It's important to us, to the world. It's that passion for improvement is a big deal. And at the bottom, this philosophy, which says, yeah, the customer we want to provide the best product to the customer in the shortest lead time with the highest quality. But our employees are our most valuable resource. It's not the machines. It's not the physical plant. It's not the design of our product specifically. It's all the people who provide all those things of value to the customer. And then, just as we did with the toast video, we need to go and see. We need to observe, and we need to create this environment where people are highly engaged and are solving problems every day, and that's Kaizen. So that is the philosophy that I learned over the years, and there's an awful lot to it. And within that, there are thousands of tools, and we hear about those. And you get those tools in Lean 101 and Six Sigma training and theory of constraints, and that's all good. QC tools and all of those things are good because they're countermeasures to the problems that we see, but they all are valueless unless we can create that favorable environment. So that Kaizen is kind of where the rubber hits the road. This is where we actually show that we're going to do something. So this drawing here is an adaptation from something that the Toyota Production System Support Center put out. And it's got these two groups of people. There's customers, and then there's our employees. Human development is basically, we're talking about the folks who work for us. We want to make sure that people are physically safe and that they feel like they can tell us their problems when there's a problem. We want them to feel that their job is secure, and above all, we want to give them a professional challenge. If we want to solve problems, this slogan here, every minute, everyone, every minute, every day, became GBMP's slogan, everybody, every day. because the only way to really deal with all these opportunities for improvement is to have every employee be a problem solver. In this case, it can be a problem solver for reducing toxic waste streams. Okay, it could just as well as reducing motion or anything else. The persons who are on the scene are the persons who can see the problems, and if we create that opportunity for them, they will help us. Okay, so my question, and this is more of a rhetorical question given the time constraints of today, but have you defined an ideal condition? What are the ideal conditions? So for in the Toyota production system, this vision of the ideal is referred to as true north, and it's saying 0 defects, 100% value to the customer, producing exactly what the customer needs, lot size 1 in sequence. Very hard to do. Look, it doesn't mean that that you do it. It means that the ideal is still there. Okay, 0 defects is an ideal. If you're a customer and you go to go shopping and you buy a dozen eggs, what do you do with those dozen eggs before they go in the cart? That's not a rhetorical question.
You check
Open
to
the
make
box
sure.
and roll
Yeah.
them to make sure they're not cracked.
Right. And in fact, I'm not sure who said that, but you actually we've developed techniques to inspect. Okay. So as a customer, I expect 0 defects. As a supplier, I'm saying, oh, that's really pretty tough. But the ideal doesn't change. So we're talking about an ideal here, and it's from the customer standpoint. Too often when we go into our work in the factory, we're more in that acceptable quality level thinking where this is the best we can do. My teacher, Hajime Oba, said it's not what we can do, it's what we should do. That's what this vision is about. Okay, so that's the idea. But I'm saying from the standpoint of looking at toxic use reduction, what is our ideal condition? And then from that, what are the target conditions? So Toyota didn't actually begin this way, but today, and they're not a perfect company, not by any stretch of the imagination. They have problems, but they have their own. I just pulled something off of their site, one of 6 major initiatives for them where they're looking at CO2 reduction in their plants. And it's one of several, and they're very serious about it. They have a target condition here. It's their environmental challenge. But it derives from that same sort of true north thinking, a vision of the ideal. Let's not provide anything to the customer that doesn't add value to the customer. So that's true north. So then there's this, so how do we go about it? Okay, so we want to progress. So this drawing, these arrows mean we're always progressing from our current condition to a higher level, heading towards true north. That's what this diagram is supposed to mean. How do organizations do this? And there isn't a formula. As I said, I think earlier, it's an adaptive change depending upon your organization, your particular challenges that you have, the market that you're in, your history. The ideal doesn't change, but the way you get there is going to be unique to you. But many organizations do start off in a chaotic condition. And the basic model here says, you have to crawl before you walk. Okay, if I can use an analogy, that before we can have a very highly specified way of doing things, we at least have to be stable. We can't. It's hard, for example, to say that we're going to have a changeover on a machine, and we want to do it the same every time if the machine itself is not stable. If the machine needs an overhaul and it never returns to the 0 point, you can't even set a standard. You're condemning your employees to constantly tweak the machine to get parts made. So standardization requires the stability first. Otherwise, they're just living in a chaotic condition. And so from standardization, we want to say, okay, we have a clear way that we're going to do this. And now we're going to see if we can do it faster. One of the mantras that was given to me was the order of improvement must be easier, better, faster, and then cheaper, in that order. We want to make the job easier and then better. And if we do that, it will become faster, just as with the toast video. And that technical science, and I'm going to talk about that just a little bit, the methods that we use and then the social science. So this person is standing at the bottom of the staircase, is looking at these problems. And today, maybe she's thinking that the problem to solve is impossible. But as she climbs the staircase, as she learns, as she gains confidence and experience, she sees that what she thought was impossible is now possible. And that is that when I talk about Kaizen, it's as much about the spirit of improvement, the confidence that that person has, and the confidence that her manager has in her, so that, so that all problems don't fall on the manager. And this is also, the same thing would apply to toxic use reduction. You can't have a process as important as this fall on just the shoulders of a few people. It's crushing. We want to get everybody involved, okay? And how do we do that? We do that through education, we do that through practice, and we follow this progression and try to always move better, always get better. Every target condition becomes our new current condition. So let me talk about these levels in just a little bit more detail. I'm going to go back to that Toyota house, and I've simplified it a little bit here. And at the base is this thing which we call stability. Okay, and among other things is the process even capable? And that would be a question that you'd want to ask from the standpoint of toxic use as well. Oftentimes, design is given to the factory and the process isn't even capable of doing it. So you have a lot of problems. People do a lot of tweaking, adjusting, inspecting, sorting, because the process is not capable of doing it. Only works sometimes. Workplace organization, simple enough, as I said, from a technical standpoint. It would be nice if we didn't have to spend so much of our time searching for things we can't find, or if because things were not organized properly, somebody got injured, or because they picked up the wrong piece because things were not organized. And certainly having equipment that works is a big deal. And I don't mean fix it when it's broken. I mean, let's do something about, let's change the engine in the oil rather than wait for an engine overhaul. And that's stability. And that is necessary before we can talk about before we can ask people to please do it the same way every time. We have to give them enough stability for that. On the right-hand side is more human conditions. Equally important, I've got language barriers in there because I know in my own plant, there were 9 languages spoken and English was not the major language. So we needed to deal with that. That was a continuous improvement problem. An opportunity was necessary so that people could communicate and let us know about improvements. In New England, it's a unique situation. We have many languages spoken and we need to, in fact, there are language barriers between engineering and production. We need to be on the same sheet of music about what we mean when we're talking about the work that we do. And that's the basis. The rest of that house really can't stand without the foundation. So here's an example, a specific example. And I picked one from just a simple 5S checklist in a chemical room. Organizations, lots of them have chemical rooms. When you go into them, you don't feel safe. There's not safe. The containers are not grounded. The chemicals are not labeled properly. So there's accidents waiting to happen, and we need to take a very proactive approach to making sure that with 5S, and if you haven't heard about this, it's 5 Japanese words, which I've not committed to memory, but the rough translation is get rid of the things that you don't need, and then put the things that you do need in order, and then keep it clean all the time, and then make sure that standard is maintained, okay? Standardized and sustained. So that, in a nutshell, is what this is about. And it sounds like a good idea, but it's oh so hard to do. Occasionally there are persons who, just of their own volition, are very, we typically pick on them because they're so well organized. Okay, this is the person who has tied her pen to a string so that it won't walk away, things like that. But this is what they have discovered that the rest of us haven't figured out yet, is that work is easier if I can find all the things that I need, and I'm not continually having to work around things that I don't need at all. it's a huge opportunity. It's an opportunity to free up space, to create safety, and also certainly to create better management of our waste streams. But here's the social part, and I have another very simple video I want to share with you that shows a condition that I think you probably are familiar with personally, and this is the human condition. Okay, so I've got two situations here I'm going to show, one good and one not so good, and both of them are right next to each other. This is a flatware drawer. Everything is kind of telling you where it belongs. You might not have Snoopy spoons. This was made when my kids were little. But everything's there. I can go into that drawer in the dark, and I know where the coffee spoon is in the morning. People just tend to put it back in order, so it's naturally organized, and we're used to that. It's normal. Now, here's another condition, however, that's also normal. We call this the utensil drawer. So everything's in there. I wouldn't go in there before dawn because there's a ginsu knife in there. Notice the way we restore order. We press everything down. So that's more of a metaphorical condition in manufacturing and offices and operating rooms. There are lots of places where that's our form of organization. And we say, oh, yes, it's all utensils, to be sure. But when we need something, who knows if it's there? We actually, my wife and I took that drawer apart, and we discovered that there were 3 sets of measuring cups in that drawer, all of them missing the half cup measure. So this is the consequence of not having stability. Okay, if we really need something, sometimes it's critical. If it's an operating room and we're missing something, it's very critical. But if we're in a machine shop and we can't find something, maybe it's not critical, but it's very important. It slows us down. And in fact, the countermeasure often is we begin hoarding. We hide our own stash of stuff so that we don't have to worry about it, and that's costly. And the same is true with with use of toxic use chemicals. They're stored very carefully. But if we can't find them, employees keep their own stashes, and I know this from my personal experience. And we discourage that, but they're doing it because they're doing it as a workaround. So having that stability is really, really important.
Bruce, I'm just going to break in real quick. We've got about 30 minutes left, and we'd love to have some time for questions and answers at the end. So if you just want to plan accordingly.
Sure. So I got just a couple more staircases to follow here. And this particular one's kind of a busy drawing. And so you'll have it in your notes, but let me just point out there's on the red at the top, we have an abnormal cycle. Assuming we had stability, we'd want to figure out how we're going to do something and in the amount of time it's going to take. So in a normal cycle, we want to design our work to meet what the customer needs. And there's a word here called takt time. That's the rate at which customer wants us to make it, not the rate we can make it. It's the rate the customer wants us to make it. It's a rate that we've described. It calibrates our work so that we understand what the pace should be. So we can work at a steady pace and it's repeatable and the job's easy to learn. And that's a good condition. But, sometimes things don't work out that way. And then we need to have a way to call for help and to fix the problem. And we need to be able to see the abnormality. It needs to be obvious. As I said, make problems ugly. Same would be true if we're looking at standardization. There should be clear standardization for use of toxic chemicals. Okay. And if there's a problem, that problem should be ugly. So the same approach would apply. Just a short video here. It's kind of funny. Those of you from New England may remember this play. We call this a razzle dazzle. Okay. This is the one when Edelman threw a touchdown pass and won the game. Okay. But that's not razzle dazzle at all. That is highly specified work where every single person on the field has seconds to do his job. It only can work if it's timed perfectly. And they say football is a game of inches, and it's a game of seconds as well. Same should be true of how we do our work. That's what I mean by highly specified work. That's our ideal, and that makes it easy for people to do their work because their work is clear. Okay. So just a couple more slides, and I want to talk about some examples that have actually come from the Institute. This idea of producing to exactly what the customer needs are. This is a golf ball plant, and I've scored a little bit of it, but it's complex making a golf ball. There's a lot of things you have to make the rubber, and then you have to extrude the rubber, and then you have to form the rubber, and then you have to mill the rubber, and then you have to coat the rubber, and then you paint, and goes through a very long process. And so starting out, you could pile up a lot of inventory, like months of inventory, months of golf balls, trying to get the product made. And that has some impact. And let's say a lot of impact on overproduction, producing a lot, because there's a lot of time to change over machines and so forth. And in this particular organization, their goal was to reduce the lead time in inventory. But it turned out that their most significant change was the reduction in consumption of energy, because it requires a lot of energy to do this. And moving from months of inventory to days of inventory was a huge reduction in inventory. They did not actually measure other waste streams, but I'm sure there were others involved there. Let me just finish the idea with lean. With where does management fit into this? Okay, if we want to move through this progression, first of all, there needs to be that strong, visible commitment. By visible, I mean be there, be out there, letting people know, not just when there's a problem, but when they're doing something right. Spend a little time to understand the details of this problem solving, so that you don't have to be expert at these things, but you need to understand why they're important, so you can convey that to your employees and build that culture where people solve problems, where they want to make problems ugly, and then give them the means to solve those problems, and then get out there, just like we did with Toast, and see the floor regularly. One of my heroes, Shingo, pointed out that the biggest obstacle is our will to improve. We don't know. We just feel like maybe nobody else cares, or maybe there isn't just isn't support. I'm not sure how my manager feels or her manager feels. So that strong visible commitment is important. So there's a couple of examples I'll just close with, and then I think we'll still have some times for questions. Are we okay on the time frame?
Yes, perfect.
Okay. So these are some examples from the Institute, and they're really nice examples. And they have to do, in this case, with its problem-solving method, where I've kind of paraphrased some of the things. And these articles are, I think, on the website, and I'm not sure if we're going to chat them to you or not, but they're definitely worth reading. They're 2 pagers, easy reads. But the point is, there was a will to improve here. So a couple of organizations have said, yeah, we feel like we can do better. And our target, we would like to have zero toxicity, but we feel we can reduce it. We feel that there's an opportunity, and it's an economic opportunity. The article that I showed you earlier basically said, if you're not attacking these environmental problems, you're not only creating a problem for the environment, but you're leaving money on the table. You're adding waste to the process that the customer doesn't want to pay for, and it's cost to you, and it's, of course, harm to the environment and your employees. So this organization had a fairly clear definition of their current condition. They had to know what was needed in the sodium hydroxide here, and I'm not a specialist with this, but let's assume that that's the condition with sodium hydroxide. I recall one time in a chemistry lab accidentally spilling some of that, and so I know what it does. And hydrogen peroxide, not so much. But the point was they were looking at a way of this is essentially cleaning. It's a cleaning process, and it used these chemicals, used water as well. and used energy. And they looked at so they had a hypothesis. They actually reached out to I'm sure it was to the Institute or the Department of Technical Assistance, and they experimented. So they had a condition, they had a hypothesis. So it's problem solving, but it was with the intent of there's got to be a better way. So in the process, they reduced the energy that they used, and they reduced the toxicity. Same thinking, so it's a lean process, but it was not focused so much on time. It was focused on producing, of cleaning the kettles with less toxicity. Here's another example. This one here is from Cape Cod potato chips. Same issue, needing to test do some cleaning in place, make sure that there was no residue left on the equipment. And they found that they experimented and found that there was a means to reduce the toxic waste. It was a totally different approach. It was cheaper, and it was also faster. So here's an example, kind of a reverse of what I've been talking about. The intent here was to reduce the toxicity, but in the process, they found out that it was actually cheaper and faster as well. So they're working on the environmental waste, and in the process, they discovered this other opportunity of lean waste being reduced at the same time and a cost savings. Just one more example, and then maybe we can go to some questions. This is a manufacturer of lenses, and they actually began this as a joint program. They took out a grant from the Workforce Training Fund to study lean, and they used the Lean and Six Sigma tools to work on toxic use reduction. And they achieved both. So it's in concert, the same persons who were working on the lean, as Mr. Ono would have described it, were working on. They already had this idea in mind that these same problem-solving tools, we can put these in the hands of the people who are doing the work, and we're going to end up with a better process overall. And they had a huge improvement in reduction of hazardous waste. And in the process, they were reclassified as a small generator, which was a big deal. So there's 3 examples, and I'm sure there are more that are available to you through the Institute, of the investment that you make in problem solving. If your company is into lean, as a planner, if you're not into it as well, you might want to check it out, and you might want to advocate that this should be part of that lean training, because it's quite possible that the persons in your part of the organization who are engaged with lean haven't really thought about how much opportunity there is to include toxic use reduction as part of that process. So thank you. Hope that's given you a little idea of how lean and toxic use reduction can be mutually beneficial. And I'm just going to stop my share. And if there are any questions, be happy to entertain them, or any discussion from you.
Thank you so much, Bruce. Just really very interesting and nice introduction to lean manufacturing. And what I really appreciate is how clearly you've been able to make the case of how TUR planning, toxic use reduction planning, and lean manufacturing can go well together. We have several comments in here, a lot of comments during your videos and stuff. So including people who were very reminiscent about seeing the paths. One of the questions that came up a couple times is the question about supply chain. And when you talk about just-in-time production, that really feels to have gone out the window. How does just-in-time manufacturing work in today's era of supply chain bottlenecks and issues.
Yeah, and so that question has definitely been in the news, and there's two answers to that. So first of all, there's a broad definition of lean that I provided at the beginning, that it's to create a culture of highly engaged problem solvers. Okay, so problem solving deals with many things, including toxic waste reduction. I think that was the message I wanted to share today, which is not necessarily related to the question of just in time. Just in time is a piece of lean, which essentially says don't make anything the customer doesn't need. Okay, but there are prerequisites to that. And those prerequisites, I talked about levelization, about this thing called Mora. The reality is, and for me, this has been a topic for 35 years. I worked in a manufacturer where we overproduced in the max, but we never were making the right thing. We had way too much inventory, but we didn't have all the right parts at the right time. The idea was to have all the right parts. That was the ideal. The reality was that because the setups on my equipment were long, I couldn't do that unless I fixed the setups. The ideal here of just in time is to eliminate all of the reasons that we need that inventory. And when we end up with a cataclysmic event like we've had in the past 20 months, reality is there is no production system in the world that will work when you have these huge swings. And that would not be new to persons who are, spent years in lean manufacturing. That levelization, that funky Japanese word heijunka that I mentioned, has to do with creating a level flow. Manufacturers, whether they are into lean or not, and most of them are not, regrettably, are not very far into it, are having no shortages. Everybody's having no shortages. We can't get anything right now. And of course, people like me are hoarding paper towels and all sorts of other things. We have a double problem with levelization. And I think it's an acute problem. It's not a long-term problem. I mentioned this to you the other day, Pam, that there is, a part of this thinking, very long-term thinking. And let me mention that of the auto manufacturers, Toyota has fared much better than their competitors because Toyota has attempted to levelize the flat flow, that flow interruption, and has not punished their suppliers. They're trying to spread that around. But the problem is there for all of us, whether we're a lean company or not, that these shortages are there. And the reality is that, strategically, we should have seen this coming. But we're not great strategic thinkers. I think as a species, we're pretty much focused on the moment. I will say certainly this last 20 months has demonstrated that, hasn't it? We can look back and say, yeah, we should have seen this coming. So we've had a lot of tactical countermeasures. And the process, something like just in time, is, I think, maybe unfairly taking it on the chin because of that lack of strategic thinking. And there's just no amount of tactics that can overcome the lack of a strategy. Okay, so I'm hopeful that going forward, it's not too soon for us to be strategic about the next type of event that we might face. But the reality is, when we have a huge cataclysmic event such as we've had, it is disruptive to any production system.
Yeah, good point. So several people have vowed to go and clean up their utility drawers this evening. So I just want to say, I'm sure that there are many households that are appreciative of what you've presented. And people who are also really interested in implementing lean and talking to their teams about lean manufacturing and embedding toxic waste reduction into it. So I'm really happy to see that. I'd love, if anybody has any questions they'd like to ask Bruce directly, we have 12 minutes. So let's, go ahead and share more thoughts about how you're implementing lean in your facilities, how you see toxic waste reduction being embedded in the lean manufacturing process, or any other questions you may have for Bruce, other than about toast.
I will just add a comment. In our business, we're seeing right now supply chain, like you mentioned, it's hard to get things, and it certainly has kind of contributed to lean. I'll say maybe unintentionally, but we are having to reduce product offerings just because of reduced availability. And fortunately, some of the stuff that's not available is more of the toxic things that are coming from the other side of the globe. So we are, unintentionally reducing toxics because we just can't get them.
Maybe that's not a bad thing. It certainly requires some rethinking around product formulation. And I'm being a little bit flip about that because, of course, you're using chemicals for a reason. So it may also be a good opportunity to step back and say, what is that reason that we're using that chemical? And is there something we can be doing? Can we be changing our process or our product formulation in a way that allows us to not depend on it?
Absolutely. It is resulting in, product reformulation for that reason, because, stuff in the US is far easier to get. It doesn't get stuck on a ship somewhere. So being able to reformulate, we are, seeing the benefits of, product substitution or material substitutions that are in fact less toxic.
So Jessica, thank you for that comment. And let me just say that I'm kind of parochial about all of this. I love to see us making and buying things here in the US. Don't begrudge other parts of the world, but we made a strategic decision a long time ago to send all that stuff somewhere else. And I would love to get it back. And I'll also say, my friend and mentor, John Shook, likes to say, never let a good disaster go to waste. So, this has been a big problem for us, but it tests our creativity. And in your case, has created that need to find another solution. So good for you.
I will say I am very scared to look at what new chemistry we are using, and if there is stuff that we have started using that maybe we're going to find out later, as always is the case when we learn more about chemistry. But it certainly is changing. Our number of raw materials is different, and the raw materials themselves are forced to be different because of availability.
Yeah, really good example. We have a question here, Bruce. How is the Great Resignation impacting lean manufacturing and just in time with staffing shortages? You have any input?
It's a mess.
Right?
It's a mess. And once again, I will say that companies that have, we look at this broader definition, which is the definition I hope you will leave with today, of a highly engaged culture of problem solvers. Yeah. These organizations are in an immeasurably better condition to deal with this problem than organizations who have 95% of their population just comes to work and does a good day's work, and 5% are supposed to solve all the problems. That's a very difficult environment. But the shortage of persons to do the work is a problem everywhere. And this, of course, is exacerbated by the fact that we have pent up demand. So even material that's just coming, on those ships sitting out in the ocean, it's not like we're receiving less material. We're just not receiving enough. We can't get it back in fast enough. So we have part shortages and we have people shortages. The idea of lean, of using our creativity to solve problems, and I think Jessica gave a pretty decent example, is something that happens in an organization where we are practiced with problem solving. But the people shortages of employees. I don't know. I think we're going to have to look back on this and see what's happening. Yeah, people are leaving the workforce. There are projections that by 2050, there's going to be a huge shortage, reduction in population. And these are things that we'll face. Speaking of looking at this strategically, we probably ought to ask not what's happening this year, but what about 2050? Who's thinking about that?
Yeah, really good point. Liz asks, how do you push these approaches back up to suppliers? Your point about their waste and practices impacting yours is a good one.
Yeah, so that's a really good question. Okay, we could almost spend an hour on that one, but I will say improvement begins. Working with suppliers begins with working from the inside out. Look at your own process. What's your relationship with your suppliers? How much information are you sharing with them? What's the interpersonal relationship between you and your suppliers? What type of communication have you got? I know from my personal experience, when things went wrong, the suppliers were an easy mark to blame because they were not there to defend themselves. You say, oh, well, the quality is the suppliers, their delivery is bad, their quality is bad. But we didn't actually have very good communication. So we were, one point we were at this point where we said, okay, well, look, at our MRB board, we're going to reject anything which doesn't meet our specification. We tried that one day and we rejected, I'm not exaggerating, everything. Prior to that, we would adjust, we would sort. I mean, there were purchase drawings that said rework is necessary. And all of that was there because we were accepting it. Okay, that was the current condition. We were living with it. And when we went back and took a look, what we discovered was we hadn't even told suppliers about the problem. We were just fixing them ourselves. We were, and then communication never got back to the supplier. There's an awful lot of opportunity to work with that external factory and get them involved. They are an important resource as well. But there's, often, again, conditions can vary by business, but often there's a lack of trust between supplier and consumer, and we're not sharing the information we should share. I would, if it were me, I would pick a couple of suppliers and I would try and experiment. Bring them in, show them where the parts go, and engage their thinking. Get everybody involved.
Great. We have one Mark who notes that they're repatriating their purchases from China, but at a huge cost, having to raise prices by 50%. The other Mark, we have many Marks, I guess, notes that the focus of today's lean manufacturing can and should be expanded to include the shortcomings of global supply chain and the waste associated with moving materials across the planet that could be sourced locally. So, some of that kind of give and take, that those trade-offs associated with really dealing with the bigger picture. Yeah. Daryl asks, are there any studies that look at the cost and waste of transportation? That would be interesting to share.
I was just going to answer that to her, that one of the food and beverage participants in our lean manufacturing course was Coca-Cola Northeast, and the case study that I'm writing up on their facility is how using lean tools, they learned that they're shipping empty concentrate containers back empty that fill a truck. And so they're looking at ways to either crush or bale them so that they're saving quite a bit in transportation. And we're calculating to turning that into emissions savings from the transportation waste. So that'll be one small case study on that.
Thank you, Joy. And in fact, there are many case studies which refer to the total cost involving, the transport. The problem is that when we look at paper savings on parts that come from other parts of the world, they tend to be based primarily on direct labor. And then we have like huge overhead multipliers on our own factories that take that small percentage of labor and make it look tremendously expensive. So wherever it's going, whether it's going on a ship or whether it's going to Mexico, there are times when it makes sense, but there are more times than not, I think, when we look at the total cost, even without improvement, even if we're working with a manufacturer who has not, let's say, engaged in this continuous improvement process, that the costs become much more, there's much more parity in the cost. But if we were to have invested the same amount of energy in eliminating waste from processes right here in New England, as we've invested in finding suppliers in distant places, and then having to transport, not to mention all the development costs and the communication costs and the problems with creating new products and making design change, all of those things, when they're all calculated in, it becomes really pricey prospect to be sourcing to the lowest cost producer in the universe. And we had a conference 8 years ago. We have an annual conference, and the theme of the conference was made lean in America. That we can do this here, and we can manage those costs here. Interestingly, when well, let's just leave it there. As I said, it's a topic, and there are many studies that show that there are lots of opportunities. One of the larger challenges, however, is that we've given up the capability. There are some parts that we no longer can make here. We no longer have the capability. We've given that technology up to other parts of the world. So it's not just a matter of cost. We outsourced that work. The technology developed, and it didn't develop here. So now we have a road back to regain that if we choose to do so.
Mm-hmm. Well, this has just been a really terrific presentation and discussion. Many comments about what a great presentation this has been, Bruce. So we thank you very, very much for sharing your expertise and your thoughts on how toxic use reduction planning can be integrated into lean manufacturing and how well those work together. I also personally want to say thank you for really calling out the need for creative teams, because that will be the topic of this afternoon's session. So inadvertently,
Perfect.
You queued me up beautifully. So thank you all for joining us. Thank you again, Bruce, for sharing your expertise and your insights. And all of the materials are available on our website. And I'm sure if anybody would like to reach out and talk more with Bruce, you would be available.
Surely. Thank you all for joining in today. It was my pleasure.
Great. Okay. Bye, everybody. See you this afternoon. Thank you, Bruce.
Thank you, Bruce. Bye-bye.